Ladies and gentlemen, welcome back to yet another interesting video, which is actually a continuation of the initial video that we've done about digestion, absorption, metabolism, and excretion. This is a video that focuses on the metabolism of fats, aka triglycerides or the lipids. Now, fat metabolism is very confusing because most students are unable to actually grasp the concepts. They prefer cramming this process. That's why I've tried to make it easier so that you can actually grasp it. Again, this video is intended to prove that no energy comes from the stomach, and also that carbohydrates are not the only energy giving foods. If any case, fats produce the highest amount of energy in relationship to carbohydrates. Therefore, in my view, fats are actually the energy giving foods. However, at the cellular level, the body does not even recognize fats, the body does not recognize proteins or carbohydrates. The body recognizes something called acetyl-CoA. That acetyl-CoA is what is going to be fed into the energy cycle to either yield energy, of course, to yield energy in form of ATP. Remember, ATP is the energy currency that the cells recognize or utilize. So when you're loading 1 gram of fat into the cycle called the Krebs cycle, and somebody in Germany told us that the word Krebs actually means cancer. I don't know if that's true or they lied to us. So you can actually confirm that in the comment section if you're from Germany. All the same, when you feed fats, 1 gram of fat into the Krebs cycle, you're going to produce a lot of ATP, basically 130 molecules of ATP, as compared to feeding glucose, which is coming from the carbohydrates, that will give you about 30 molecules of ATP. From that, you already see that fats per gram are actually the highest in terms of yielding ATP. However, let's jump into this. Understand that fats, most people, when you talk about fats, they're thinking about triglycerides only. But we have 3 categories of fats. One is the triglycerides. That is basically what we're going to talk about here in terms of this metabolism. Number 2 is phospholipids, a very important one in terms of formation of cell membranes. So your cell membranes are actually made up of phospholipids, and those are fats. And number 3 is cholesterol, the one that we constantly blame for our health problem, and we've actually unlearned that. So the phospholipids and the cholesterol are very important in formation of vitamin D, information of cell membranes, information of nerve coverings that are called the myelin sheath. Remember, your nerve cells are like electric wires, so they are insulated by cholesterol and phospholipids. Also, remember, your brain is cushioned 80% by cholesterol, and that is actually fat. So all these things, and sex hormones and most steroids like cortisols are actually coming from cholesterol. Also, for you to absorb the fat soluble vitamins A, D, E, and K, you must have, or you must consume foods that are rich in these fats. So therefore, we should never demonize fats. The only problem is we don't understand the difference between the saturated and unsaturated fats. And possibly in one of the videos, I will explain that so that you can actually understand what we mean by saturated and unsaturated fatty acids or fats. Okay, so these fats, for you to absorb them, remember they're coming in from 3 things. Number 1, we are getting a very good percentage from the diets, but this can be about 15 to 20% of the fats that you're consuming coming in to be absorbed from the diets. Number 2, we have, of course, the liver. So from the liver, we synthesize fats. 80 to 85% of cholesterol is actually synthesized in the liver. So are phospholipids, and triglycerides can actually be gotten from the liver through converting fructose, which is the fruit sugar and the honey sugar, into triglycerides, which are still fats. And that's how we end up getting a fatty liver. So the diets are coming in, the liver makes the fats, and of course the stores. So these are the sources of the fats: diets, the liver, and the stores, which is in the fat cells. We can use that to harness energy. But remember this, for you to actually get proper absorption of fat and not get that stool that is covered with fat, the one that when you flush in the toilet it doesn't go, or it doesn't flush itself, that tells you must have 3 organs that are very functional. Number 1 is a functional and a non-inflamed small intestine, where absorption happens. And number 2, the liver, that is going to give you the bile salts that will help you emulsify or make this break down these fat globules into smaller ones, for you to actually absorb them with ease together with the fat soluble vitamins. And then we have the pancreas, which produces the enzyme called lipase that now helps you to chop down those larger molecules of fat to actually make the monoglycerides for ease absorption. So those three organs are very important in terms of absorption of fat. But remember, dietary fats are the ones that we're actually referring to here as triglycerides. And the triglycerides are acted upon by an enzyme from the pancreas that is called lipase. This lipase, we will now break it down because it has to do, this is actually how the triglyceride looks. A molecule of glycerol with 3 chains, which are very insoluble. Okay, so when you break it down, you release the glycerol and then you release these free fatty acids. That is what is actually being explained here. So you release monoglyceride and then you release the free fatty acids plus glycerol. Now these 3 are easy to absorb. They will be absorbed into the lymphatic system. Remember, fats are not absorbed into the bloodstream. We said that. We said they are absorbed into the enterocytes, in the lymphatic system, and they are carried all the way to the heart. And we will explain that. So these 3 are absorbed through the gut wall, and then when they get into the enterocytes, they have to again to be recombined to form back the triglycerides. So you break it down for absorption. Once it is absorbed, you combine the triglycerides again, the monoglycerides and the free fatty acids plus glycerol to form a triglyceride. That is another fat into the system. Now, that triglyceride has to be combined with cholesterol. Remember, cholesterol is actually coming from the synthesis in the liver. So now you combine the triglyceride plus cholesterol together. Now, this is a very insoluble compound because it's just fat. So what do? We must coat it with something called lipoprotein. Lipoprotein is a lipid and a protein. So basically, a vehicle that makes this lipid to look soluble into the system or in blood for easy transportation. This is where the LDL is coming in and the HDL is coming in. However, when you combine cholesterol and triglyceride into the system, you coat it with something called chylomicron. Now, this chylomicron, inside the chylomicron, we have the cholesterol and we have the triglyceride. But the chylomicron is actually a type of vehicle that carries these fats. It's actually a lipoprotein. Okay, so it makes them very soluble, and then you take them into the thoracic duct, you take them into the left subclavian vein, which deposits it into the superior vena cava, not inferior. This is the superior vena cava, the one that is coming into the heart. Now into the heart, out into the lungs to get some oxygen, back into the heart, and now it's pumped out into the system. We've explained that in the other video. So simply understand, you absorb fat, you coat it into a chylomicron, transport it to the heart, it's pumped out into the system for either storage into the fat cells or for metabolism. And now, listen to this. These fats are not going to clog your arteries. No. Why? Because in your blood vessel, you have a lining here called the endothelial lining. That endothelial lining, its function is to release an enzyme called lipoprotein lipase. The function of that lipoprotein lipase is to hydrolyze this chylomicron and the cholesterol and the triglyceride inside this chylomicron so that they can easily diffuse into the cells for either storage or to be converted or synthesized to get energy, the ATP. So at this level, when you're pumping fats into the cell, they are still fats. But in the cell, where we now have internal digestion and metabolism, there's a whole different pathway of these fats. Now that we've carried it into the cell, we take it into the organelle called the mitochondria, which is the energy machinery of the cells. At the mitochondrial level, that's where genes start to play roles. That's where mutations start happening. That's where cancer starts to hail from at the mitochondrial level inside the cell. But let me take you to the metabolism of these fats in the cell, in the mitochondria. Understand, when you're bringing in these fats into the mitochondria, you're not bringing them in as a fat, you're bringing them in as acetyl-CoA. So let's go back and understand where we got this acetyl-CoA from, which is a raw material for the Krebs cycle. Now, the fats that you brought in, the triglycerides, have to be chopped off to release by the lipases. Lipases are enzymes that actually break down fat. So you chop off the head is the glycerol, you release the glycerol, and then you release these tails that are called the free fatty acids. Okay, now you've released free fatty acids and glycerol, and these are 2 compounds, but the 2 compounds are going to yield you multiple energy because the fat metabolic pathway is similar to the carbohydrate metabolic pathway. That is the glycolysis. So when you eat a carbohydrate, you break it down to glucose. This glucose is taken through several steps here. And I remember when I was studying in campus, this was a very hard channel to study because it had about 20 steps of glycolysis. So glycolysis is a process of breaking down glucose to get pyruvate. Okay, so this glycolysis is a channel that yields you pyruvate, and guess what? The glycerol that you're actually releasing from breaking down the triglyceride, the fat, is going to be pumped again into the glycolic pathway to give you pyruvate. That is one way fats give you energy. So they release glycerol that is pumped into the same channel with carbohydrate metabolism, which is glycolysis, to actually yield you pyruvate. Now pyruvate is converted to acetyl-CoA, and this is what is fed into the energy pathway, or the cycle that is called the Krebs cycle or the citric acid cycle, to later yield ATP that will be used by the cells. That is one pathway. The second pathway, you broke down these triglycerides into free fatty acids, the 3 free fatty acids. Now these free fatty acids, through a process called beta oxidation, another whole channel, beta oxidation, you will yield two things. One, free fatty acids will be converted direct to acetyl-CoA. Remember, we want this acetyl-CoA for our raw material, for our energy pathway, for our energy cycle. But the same process that is called beta oxidation will yield something called NADH, NADH or FADH2. These are also very potent and they have higher energies. So these two will be fed into something called the electron transport chain. Now, this is for the students who actually want to understand this better. So you break down free fatty acids through beta oxidation to yield acetyl-CoA that will be pumped into the Krebs cycle. Or you actually use the beta oxidation to yield other compounds that are NADH and FADH, pump it into the electron transport chain and yield ATP. Look at it this way. The fats are giving you one pathway, which is beta oxidation to get acetyl-CoA loaded into the cycle, you get energy. That is one. Number two, you're yielding NADH loaded into electron transport chain to give you energy. That is number two. Number three, you are releasing glycerol into the glycolic pathway to give you pyruvate, to give you acetyl-CoA, pumped into the chain, you get ATP. Multiple energy sources. No wonder 1 gram of fat will give you 130 molecules of ATP. A lot of energy. But 1 gram of glucose or carbohydrates will yield only 30 molecules of ATP. Therefore, to you, which one is the energy giving? Is it the fat that will give you 130 molecules of ATP, or the carbohydrates that will give you 30 molecules of ATP? Now you have your answers. Again, at this level, your cells does not recognize carbohydrates or does not recognize fat or protein, because again, proteins can be converted to the same acetyl-CoA to give you energy, which is equivalent to the energy that you get from the carbohydrates. So carbohydrates and proteins are at par in terms of ATP that will be produced per gram. But at this level, the cell does not recognize you ate meat, or you ate fats, or you ate carbohydrates. So at this level, those three macromolecules stop to exist. The cell knows only acetyl-CoA. And here, you will simply understand that 1 gram of whatever is coming from the fat is giving you 130. 1 gram of whatever is coming from glucose is going to give you 30. That's how the cell recognizes that fats are highest in energy. So you already know that no energy is coming from the stomach. And number two, carbohydrates are not energy-giving foods. Fats are, according to this platform. Of course, this is the metabolic pathway. Now, this one is another one that has a lot of steps, and those steps yields carbon dioxide, or the end product shall be converted to ATP to give you energy. So that is how it is metabolized. But this is the dietary carbohydrates and the dietary fats. Okay, but I want you to understand this. We say there are three ways where how you get fat. Okay, the three sources. The diet. This one is the channel for the dietary fats. How about the liver? The liver synthesizes fat in something called the de novo synthesis of cholesterol for fats. So the liver has the capability of making fats, and actually a lot of the fats in the system are coming from the liver. 85% of it is actually coming from the liver. Now, why is the liver making so much fat or so much cholesterol? It's actually making it to actually help your system. We've talked about the function of cholesterol. You can actually check that out. But cholesterol is very important, and phospholipids in terms of the cell membranes, the brain, the nerve function, the sex hormones, the vitamin D, the cortisol, which is a stress hormone, and all that, and even the skin and the vision. But this, from the stores and from the diet, you will follow this platform. Because now when you're not eating carbohydrates, your body finds need to go and tap into the fat cells to release acetyl-CoA so that you can actually use it to synthesize ATP. The same to diet. But in the liver, when you've synthesized these fats, the triglycerides in the liver, what is going to happen is they are going to be combined with a fat soluble vehicle, the LDL, low density lipoprotein. That is not a type of cholesterol, please. Understand, LDL is a vehicle that is supposed to carry what is made in the liver to be ferried into the bloodstream because it is soluble in blood, and fats are not soluble in blood. So we must package the fats in a vehicle that is soluble in blood, and that vehicle is LDL, the one that you people call the bad cholesterol, only because it's carrying cholesterol from the liver into the system. But the one that's actually carrying cholesterol from the system back to the liver is HDL, and you people call it the good cholesterol. Okay, so it's time for us to unlearn that. So you package the fats into LDL, or very low density lipoprotein, VLDL, and then that is carried into the bloodstream all the way to the fat cells for storage or for this process again. But I want you to know this. We already said that these fats that are being carried in the bloodstream, they have to be hydrolyzed by this enzyme called lipoprotein lipase so that they can actually get into the cells for either storage or for synthesis of energy. Now, this enzyme here is very important. It's actually produced by the cells that line the blood vessel wall. So the problem is, anytime there's inflammation of this blood vessel wall, and what causes inflammation? Kindly mention in the comment section the 3 inflammatory foods that you know. Add on that list alcohol, add on that list cigarette smoking, but I want you to mention the 3 inflammatory foods in the comment section. So those foods and those substances destroy these cells that actually make the lipoprotein lipase, and now we are unable to hydrolyze fats. So they'll stick in blood, and that can be a serious problem because they can actually clog small arteries that actually supply the brain, supply the heart, and you can end up getting a heart attack. So here, our problem is not the fat. Our problem is what caused inflammation here, what destroyed the production of lipoprotein lipase, what caused the diminishing in hydrolyzation of fat so that they can actually diffuse into the cells for storage or for energy synthesis. Now you know. So stop blaming fats for clogging your arteries and start focusing on what is causing inflammation in your blood vessels that is actually causing you problems. And that is actually the foods and the diets and lifestyle that we actually live in. So this is basically fat metabolism, and I hope from this you start focusing your energy on burning fat more than burning the carbohydrates for energy. So excessive consumption of carbohydrates is just going to make you fat. But on this channel, that's just metabolism to get energy. There's something here that we need to note. When you're not eating carbohydrates, or when you are on keto diets, what's going to happen is this platform is not there unless glycerol is coming in to give you pyruvate for acetyl-CoA. But this platform is actually shut. So we're utilizing this platform to get acetyl-CoA. Now, this is why it gets interesting. So let's say you've been consuming a keto diet. You'll get the triglyceride from it because of high fat. This will be converted to acetyl-CoA. Part of it will be converted to ATP, but excess of it will end up being converted to ketones. And ketones are highly acidic, so they can actually lower the pH of your blood. When they lower the pH of blood, if you have functional liver, functional kidneys, and functional lungs, you're safe. Why? Because this is what we call metabolic acidosis. Remember, they are highly acidic, so they make the pH of blood low. They cause acidosis. That acidosis is actually balanced by the kidneys. They will either excrete excess hydrogen ions to bring the acidosis down, or they will give you bicarbonates to actually neutralize the acidic pH so that you can actually maintain an optimum pH around the cells. If it is in the lungs, you will excrete a lot of CO2, the carbon dioxide, so that the weak carbonic acid is destroyed, is actually brought down, and the system stabilizes. So you need functional lungs, you need functional kidneys, and also the liver to detoxify this. But understand this. This process is called ketosis when you're not eating carbohydrates. So somebody who is consuming a lot of carbohydrates and consuming a lot of fat, they'll end up producing excess of acetyl-CoA that will be converted to ketones. And because we have glucose in the system, you'll end up having diabetic ketoacidosis. People who have diabetes have so much from this condition that is called DKA, the diabetic ketoacidosis. Why? Because they have a lot of glucose in the system, they cannot utilize it, and the system thinks they are starving, so it turns to the fats to burn it to get ketones. Now they have ketones and they have glucose in the system that they cannot utilize, and now that's the problem, because again, diabetes or sugars are destroying the kidneys and that's how they cannot be able to excrete excess acids from the system to balance the acidic pH. Now they have two tragedies. One, they have high glucose and high ketones in the system, getting into acidosis. And number two, they don't have mechanisms of the kidneys to actually help them to excrete excess acids and balance the pH, because the function of the kidney is to actually do the acid-base balance, okay? But if you're not consuming carbohydrates, therefore, you're not going to get excess acetyl-CoA, or rather, you're not consuming carbohydrates, therefore, there's no excess glucose in the system. Now, the body has to turn to alternative sources of energy, which is basically the fat cells. Burn the fat in the fat cells, produce energy in form of ATP, and then the rest will be converted to ketone bodies, and ketone bodies are actually the best energy sources for the brain and the system generally. So this will not take you into ketoacidosis or DKA. This one is what we call the ketogenesis, where we don't have glucose and the body turns to the fat cells to actually burn the fats to give you ketones that are best energy sources for the brain and the cells. And I always tell people, the more you consume carbohydrates, the more you expose your body to easy ways of finding energy. Therefore, the body does not see need to go and burn fat to give you ketone bodies. That is how you start adding weight, because you're producing excess of this in the glycolysis, and excess of fats, they are stored in the fat cells, are growing bigger. But if you're not consuming carbohydrates, that means you're eating keto diets, you're going to get ketones, or you're going to get acetyl-CoA that will give you energy. And these are best energy sources for the body. Why? Because one, they are anti-inflammatory, so they heal inflammation. Number two, they are the ones that actually suppress the growth of cancer cells, because cancer does not know how to utilize ketone bodies for energy, but your body cells know how to utilize it. So that means you'll suppress the multiplication of cancer cells because they rely on glucose and they don't know how to utilize ketone bodies. And lastly, ketone bodies, apart from them just suppressing growth of cancer cells, apart from them just suppressing the inflammation, they also boost your immune system, because they are very good. Because when you're fasting, you're actually getting more ketone bodies that boost your immune system, and that can destroy the cancer cells. But look at it this way: when you're fasting most of the times and you go to the laboratory and do a urine test, of course you'll see ketones plus, high ketones in urine. That should never scare you. Don't allow them to tell you that is ketoacidosis. No, that is you being in the ketotic stage or the ketogenesis stage. Therefore, you're yielding ketones that are being excreted out through a urine, and that's just the normal function of the kidneys. That's how we balance the acids and the bases in the system. So I thought you should understand this. Once you understand this, you stop saying carbohydrates are energy-giving foods. You stop thinking just because you've eaten, now you have energy. Your distended stomach is just going to fool the body, and the body will give you, the brain will give you the dopamine, and the dopamine will make you feel good for eating food. So you are just a dopamine addict, but you don't know. So it's time for you to overcome foods, the cravings that are coming in as a result of carbohydrates, by consuming more of the fats and more of the keto diets. I thought you should know that.